Here's the real-time solution followed by an elaboration and a very interesting insight. The number of such arrangements is the same as the number of ways in which we can divide a group of 8 guests into 2 groups of 4 guests each. First group, there are 8 options for the first guest, 7 options for the second, 6 for the third, and 5 for the fourth. 2 points to remember. 1. Since the order by which we selected the guests doesn't matter, we must divide this expression by 4 factorial. 2. By selecting the first group of 4 guests, we also define the second group of 4 guests. Therefore, the number of possible arrangements for the second 4-guest group is 1. Always simplify before you multiply. 4 factorial is 24. 8 times 6 is 48. 48 divided by 24 leaves behind 2. 7 times 5 is 35 times 2 yields 70. Answer choice C. Even though we solved this question relatively quickly, this is not an easy question. Let's solve it slightly more slowly and elaborate. As previously mentioned, the number of such arrangements is the same as the number of ways in which we can divide a group of 8 guests into 2 groups of 4 guests each. In other words, we don't necessarily have to imagine 8 people running around 2 different hotel rooms. It's sufficient to create the first group, which contains 4 guests. This will automatically form the second group, which will have to contain the 4 remaining guests. Lomo would have worked just fine here, but one of the formulas we derived based on Lomo is included in this takeaway. When the question includes selection of items whereby the order doesn't matter, committee, a team, or as was the case here, guests at a hotel, we need to use this formula. Please memorize it. The number of ways to select k items out of n items whereby the order doesn't matter is n times n-1 times n-2 k items, and since the order by which we selected the items does not matter, we divide by k factorial so as to ignore the unimportant internal arrangements of these k items. Similarly, the number of ways to select 4 hotel guests out of a party of 8 is 8 options for the first guest times 7 for the second times 6 for the third times 5 for the fourth divided by 4 factorial. Gabish? Another very interesting, little-known aspect of this process is that the number of ways to select k, so 4 items out of n, so 8 items, is equal to the number of ways to select n minus k, so 8 minus 4 is 4 items out of 8 items. Basically, I just told you that the number of ways to select 4 out of 8 items is the same as selecting 4 out of 8 items. I know it doesn't seem that impressive when the number which is selected is exactly half of the larger number, but please know that it works even when this symmetry is absent. The number of ways to select 2 out of 5 items is equal to the number of ways to select 3 out of 5 items. And we can prove it. When selecting 2 items out of 5, we have 5 options for the first item, 4 options for the second item. Since the order does not matter, we divide by 2 factorial. 20 divided by 2 is 10. When selecting 3 items out of 5, we have 5 options for the first item, 4 options for the second item, and 3 options for the third item. Since the order does not matter, we divide by 3 factorial. 5 times 4 times 3 is 60, divided by 6 also yields 10. In other words, we just proved that it doesn't matter whether we start with the first or second group, the number of ways to select either is the same. Back to the question. Since by selecting the first group, we already selected the second group really has no leeway. Its number of options has to be 1. If you're not convinced by now, you can also prove this 1 mathematically. Since after selecting the first 4 guests, we have exactly 4 guests left, there are 4 options for the 5th guest, 3 options for the 6th guest, 2 options for the 7th guest, and 1 option for the 8th guest. Since their internal arrangements do not matter, we must divide 4 times 3 times 2 times 1 by 4 factorial, which yields 1. Since we are after selecting the first group and the second group, we multiply these two figures. Always simplify before you multiply. 8 times 7 times 6 times 5 divided by 4 times 3 times 2 times 1. The 8 cancels with the 4 and the 2. 6 over 3 is 2. 2 times 35 is 70. The correct answer choice is C. Please review this video before taking the test and ensure that you've memorized this entire important takeaway.